Well, in this assignment, we make use of different rules on exponents. Let's do the first problem. First, let's simplify the expression in the numerator. Here we have to apply two rules. One rule relates to the product because we have two factors inside the parentheses, and each factor should be taken to the third power. And the second rule is the rule of power to power. So 6 should be taken to the third power, and 6 cubed becomes is 216. And I hope that by this time you already learned some of the powers, perfect cubes and perfect squares of many numbers. And when we have to take this factor to the third power, according to the rule, we need to multiply the exponent. So we need to multiply 4 by 3. That gives us 12. And we will leave our denominator because there is nothing to simplify. Next, we will apply the rule of the quotient rule, and we need to subtract. The interesting point here, in the denominator, the power is a minus, but nothing wrong with this. We just apply the rule directly. So that becomes 216, and we need to subtract the powers according to the rule. So we subtract 12 minus, and we are subtracting minus 3. This is what we do. And since we don't have anything in the denominator, so we don't put 1 in the denominator. So that becomes 216 and y, and 12 and minus minus becomes plus 3. So the final answer is 216 y to the 15th. This is our final answer. In our second example, again, the application of two rules that each factor should be taken to that power. But as I advised, before we do anything, we really need to address this negative exponent. So we will first use the rule of the negative exponent, and then our power becomes plus 2. And now we can apply the rules that I mentioned before. Each factor should be taken to the second degree. So 3 squared is 9. And here we need to multiply 2 powers. Minus 1 multiplied by 2 is minus 2. And according to the rule, we never, in our final answers, we cannot keep negative exponents. So we really need to address this minus exponent here. And of course, we can use the rule again, the negative exponent rule again, putting 1 here, and then x squared goes on the third tier below. And we already discussed it in class when it happens. We keep the middle part untouched, and whatever is on the bottom goes up. So the answer is x squared over 9. And also, this is a good thing to remember whenever we have something like this, and a variable with a negative exponent in the denominator, it's always this answer. So it always goes up with a positive exponent. So it's a good tip to remember. But this is the final answer for the problem itself. The third example is kind of easy. In the numerator, we just multiply the coefficients 2 by 3, 6, and add the exponents 3 according to the product rule. 3 plus 7 is 10. And then we just rewrite the denominator. Can reduce here. Ooh, what happened here? 6 x to the 10th, we will rewrite. Okay. Reduce by 3, so 2 and 3 here. So we keep 2. Using the quotient rule, x 10 minus 6, and still keep 3 here. So the final answer becomes 2. x to the fourth over 3. Oh, yeah. But I believe that in your initial problem somehow. Oh yeah, everything is correct. Okay, so this is our final answer. This is our final answer. And the last problem here, again, two rules at once, negative exponent and rational exponent. As I advised you in class, you first attend to the negative exponent, and then the problem becomes this one. And then you just follow the rule. So the number goes inside the radical sign, and the denominator shows what kind of root we need to extract. In this case, it's a cubic root of 125, and definitely this is 5. So the final answer is 1/5.